Greatest common factor, or GCF. GCF is the greatest factor that divides two numbers. In this video, we are going to solve for the GCF of two or more numbers, and we will also have worded problems about GCF. Let's have some examples. We have here the numbers 24 and 18. To get their GCF, we are going to do prime factorization. So for 24, the factors of 24, there should always be a prime number on one of the factors. So our prime number here will be 2. 2 is a prime number because its factors is only itself and 1. And then 24 divided by 2, that is 12. We can still factor out 12. Its factors will be 2. 12 divided by 2 is 6. We can still factor out 6. Its factors will be 2, and 6 divided by 2, that is 3. So we can list down the factors here for 24. So its factors are, we have 1, 2, 3. We have 3 2's and 1 3. And listing down, that will be 2 multiplied by 2 times 2 times 3. And for 18. Let's get the factors of 18. So again, prime factorization always start with a prime number. So we can put here 2. 18 divided by 2, that is 9. And the factors of 9, we have here 3. 9 divided by 3 is 3. So the factors now of 18, we have 2, 3, and 3. Okay, so list that down. So listing, we have 2 times 3 times 3. And the numbers that are common between 24 and 18, we have 2 and 3, and there's also 2 and 3. So our GCF now, our greatest common factor will be 2 times 3. That will be equal to 2 times 3 is 6. Okay, let's have another example. The numbers 96 and 520. So the factors of 96 again start with 2. So 96 divided by 2, that will give us 48. And 48, we can still divide that by 2. So 48 divided by 2 is 24. 24 again divided by 2. So 24 divided by 2 is 12. And 12 again divide by 2, 6. And for 6, lastly, we have 2 and 3. So the factors of 96, that will be, okay, let's encircle the factors. We have here 1, 2, 3, 4, 5. We have 5 2's and 1 3. So listing down, that will be 2 times 2 times 2 times 2, and lastly, or rather 1, 2, and 3. How about for 520? Let's get the factors of 520. So again, use 2 as the factor. So 520 divided by 2, that will give us 260. So 260, we can still factor out that by 2. So 260 divided by 2, that will give us 130. 130, again, we can still use 2. 130 divided by 2 is 65. And 65, okay, its prime factor now will be 5. And 65 divided by 5 is 13. So our factors are, we have 1, 2, 3. We have 3 2's, and then 1 5 and 1 13. And listing down, we have 1, 2, 3 multiplied by 5 and 13. And then our common factors. So our common factors, we have 1 2, 1 2, 2 2's, 3 2's, and there are no more. So we have here 3 2's as the common factors. So our greatest common factor now will be our GCF. That will be 2 times 2 times 2, and thus will give us 2 times 2 is 4 times 2, that is 8. Okay, so next number. We have the numbers 102 and 435. The factors of 102. We can use 2 as a factor. 102 divided by 2 is 51. And 51, its factors will be 3. 51 divided by 3, that is 17. So for 435, we cannot use 2, but rather there is 5. 5, and then we have here 87. So 87, we can factor that out. Our first factor will be 3. 87 divided by 3 is 29. Okay, so for 102, our factors are, we have 2, 3, and 17. So listing, the factors of 102 are 2 times 3 times 17. And for 435, the factors of 435, we have 5, 3, and 29. So listing down, we have 5 times 3 times 29. And the common factors here, or the common numbers between the two, we have only 3. So the greatest common factor now, the greatest common factor of 102 and 435 is 3. Another example, we have the numbers 48, 76, and 54. So we have 3 numbers here. Let's find their greatest common factor. So for 48, its factors will be, again, let's start with 2. 48 divided by 2, that's 24. So we can still factor out 24. So we can still use 2. 24 divided by 2, that will give us 12. And then 12, we can still use 2. So 12 divided by 2 is 6. And for 6, we have here 2 and 3. Excuse me. For 76. Okay, so for 76, we can use 2. 76 divided by 2, that's 38. And for 38, we can still use 2. So 38 divided by 2 is 19. For 54, we can still use 2. 54 divided by 2, that's 27. And for 27, we cannot use 2, but rather we will use 3. 27 divided by 3, that is 9. And the factors of 9, we have 3 and 3. So listing down, we have 48, 76, and 54. So first, let's get the factors of 48. So the factors, we have 1, 2, 3, 4. We have 4 2's and 1 3. So listing down, we have 2 times 2 times 2 times 2 times 3. And for 76, its factors are 1, 2. So we have 2 2's for 76. So listing down, 2 times 2, and let's not forget the number 19. So that will be 2 times 2 times 19. And for 54, so for 54, we have 1 2, 1 3, 2 3, 3 3's. So the factors of 54, we have 2 times 3 times 3 times 3. Let's get those that are common. So the common numbers, or the common factors, we have 2 and we also have 3. So 3, 3. Or rather, 3 is not a common factor. Okay, so let's erase this. Since 76 has no 3. So therefore, it is only 2 that is common between the 3 numbers. So our GCF now, for 48, 76, and 54, our GCF is only 2. So this is our final answer. Josie and Mary bought candies and biscuits to be divided and distributed to school children. There are 42 candies and 38 biscuits. They want to give all the candies and biscuits and create identical sets for all children. What is the greatest number of identical sets they can make using all the supplies? Okay. For this problem, we can easily identify that this is a problem for greatest common factor, or GCF, or greatest common divisor, or GCD, because of the words greatest number and identical sets. So since we now know that this is a GCF problem, we are going to find the greatest common factors. So the numbers, we have 42 candies and 38 biscuits. So using prime factorization, let us factor out 42. So we can use 2 here, and then 42 divided by 2, that will be what? That will give us 21. And then 21, we can still factor this out. We have 3. 21 divided by 3 is 7. So 3 and 7, they are already prime numbers. For 38, we can use 2 here. So 38 divided by 2 is 19. So 19 is already a prime number, so we cannot factor that out. Okay, let us list down the factors. So for 42 we have 2, 3, and 7. Okay, so listing, we have again 42, we have 2, or okay, so let's multiply that. So that will be 2 times 3 times 7. And for 38 we only have 2, and that is the number 2 and 19. So listing the factors of 38, we have 2 times 19. And the common factors, we only have the number 2. So the GCF now of 42 and 38 is 2. So there will be 2 identical sets for candies and biscuits. Problem number 2. Joel has 56 nails, 84 nuts, and 64 bolts. He wants to create identical sets with all these things. What is the greatest number of identical sets Joel can make using all his supplies? Okay, so let us first identify the words that will give us a hint if this is a greatest common factor. Okay, greatest common factor problem. So we have here the greatest number of identical sets. So this is a GCF word problem. So to do this, we are going to factor out the given numbers. We have 56 nails, so we have here the number 56. And then we have the 84 nuts and 64 bolts. So let's factor out 56. So for 56, we can use the factor of 2. So 56 divided by 2, that will give us 28. So for 28, we can use 2. So 28 divided by 2, that is 14. So for 14, we still have the number 2. 14 divided by 2 is 7. So for 84, our prime factorization will be, okay, we have here the number 2. 84 divided by 2, that is 42. And we can still factor out 22, or rather 42. So we can still use 2 here. So 42 divided by 2, that is 21. So for 21, we can still factor that out. That will have 3 and 7. And for 64, our factors, okay, let's use 2. So we can use that. 64 divided by 2, that is 32. And then 32, so for 32, we can still use 2. So 32 divided by 2 is 16. And then for 16, so we can still use 2 here. So 16 divided by 2, that will be 8. And for 8, we have 2 and 4. And lastly, for 4, we have 2 and 2. Okay, so let us now count the number of factors. For 56, we have 1, 2, 3. We have 3 2's. For 84, we have 1, 2, we have 2 2's, 1 3, and 1 7. And we also have 1 7 for 56. For 64, we have 1, 2, 3, 4, 5, 6. We have 6 2's for 64. Okay, let us list down the factors. So again, for 56, we have 2 times 2 times 2 times 7. And for 84, we have 2 times 2 times 3 times 7. And for 64, we have 1, 2, 3, 4, 5. 5 2's, or rather 6 2's. Okay, so let us get the common factors. So we have 1, 2, 3, 1, 2, 1, 2, 3. So we have 2 2's that are common among the 3 numbers. So we have here 2 2's. So our GCF now for the 3 numbers will be, that will be 2 times 2. So our GCF will be 2 times 2, that is 4. So there will be 4 identical sets Joel can make out of 56 nails, 84 nuts, and 64 bolts. Problem number 3. Luis is planning to give his friends identical number of marble sets with different colors. If he has 96 red marbles, 80 green, and 100 blue marbles, what is the maximum number of identical sets he can make? Okay, so let us first identify if this is a greatest common factor problem or a greatest common divisor problem. So the maximum, so we have here maximum number of identical sets. So this means that this is a GCF word problem. So to solve this, we will perform prime factorization. So our numbers, we have 96, 80, and 100. So the factors of 96, let us start with 2. So 96, so 96 divided by 2, that will give us 48. 48, we can still use 2 here. So 48 divided by 2, that is 24. And then for 24, we still have 2. 24 divided by 2 is 12. For 12, we have here 2. 12 divided by 2 is 6. And for 6, we have 2 and 3. And let us factor the number 80. So for 80, let us start with 2. So 80 divided by 2 is 40. So for 40, we can still use 2. 40 divided by 2 is 20. And for 20, we can still use 2. 20 divided by 2, that is 10. And for 10, we have 2 and 5. For 100, okay, so for 100, let's start with 2. 100 divided by 2 is 50. And then for 50, we have 2. 50 divided by 2 is 25. And for 25, we have 5 and 5. Let us now list down, or let us encircle first the factors. So the factors of 96, we have 1, 2, 3, 4, 5. We have 5 2's and 1 3. And for 80, we have 1, 2, 3, 4. We have 4 2's and 1 5. And for 100, we have 1, 2. We have 2 2's and 2 5's. Let us now list down the factors. So for 96, our factors for 96, we have 5 2's. So 2 times 2 times 2 times 2. That's 4 2's times 2 and 1 3. For 80, so for 80, we have 4 2's. So 1, 2, 3, 4, and 5. And for 100, we have 1, 2, and then 2 5's, 1, 2. So let us now find the common factors. We have how many 2's? So we have here 2 2's. So the common factors for the three numbers are 2 2's. Okay, so our greatest common factor now will be, so GCF will be 2 times 2. So our GCF here will be equal to 4. So there will be 4 sets, or maximum number of identical sets, that Luis can make out of 96 red marbles, 80 green, and 100 blue marbles.